Okay. Hello. Hello. Screen is visible now. So concentrate. Okay. So induction motors, faults and protection. Okay. Okay. Iron and copper losses. Right. So these are the losses when we are considering uh, or when you are studying the motors, right? But when we are considering the power system application, that time we are using the large motors. Okay, we are using three-phase induction motors there. So if we consider as per the view or point of this power system protection, we are considering the phases, right? So if there is any fault between the phases, that is phase to phase fault or earth fault, such faults may occur there. Okay, and interturn faults are there. Screen is visible. Screen is visible.
Yes, ma'am.
Okay, and interturn fault may occur there. Okay, interturn fault means these are the winding faults. Okay, means if there is any failure of the insulation, that is nothing but the interturn fault. Okay, so faults in motor windings are generally occur due to failure of insulation, and it will produce the heat again. Okay, in the windings of the machine. So that is nothing but your interturn fault. Okay, and phase faults are rare because enough insulation is provided between the phases. Okay, so phase to phase faults are rarely occurring in these induction motors, and earth faults are more likely occur in induction motors. Okay, means any one of the phase get there. So that is nothing but the phase to earth fault. Okay, so such earth faults are occurring, means it is not only the phase fault. Earth faults also include if that equipment get also there. So or if that means stator core. Okay, and stator windings get there, means all the three phases we are considering here. So that is also considered as a earth fault. Then interturn fault, that is phase to phase fault, if occurs, lead to earth fault. Okay, means if that phase to phase fault also occurs, sometimes it will lead to the earth fault, means there is a double line to ground fault is also there. Okay, means fault is not occurring between the two phases, not only occurring between the two phases, but there is double line to ground fault also. Okay, single line to ground fault, double line to ground fault is also there. So we have to provide protection against this stator faults. Then rotor faults. Okay, rotor faults are there. So these faults are more likely occur in wound rotor machine. Okay, wound rotor machine. Then wound rotor means which type of motor or machine? Rotor faults are occurring in the wound rotor machine. Wound rotor means which type? What are the types of?
Squirrel cage.
Yes, squirrel cage and there are two types of rotors, right? Na? Squirrel cage and slip ring, right? So slip ring is nothing but the wound rotor. Okay, so remember this. So mostly faults are occurring in the wound rotor. Wound rotor means it is the slip ring type of induction motor. Okay, so then faults on wound rotors may be either earth faults or interturn faults, which occurs due to several mechanical and thermal stresses, because we are using their brushes. Okay, and means slip rings are slip rings are there. So due to slip rings, there may be some mechanical and thermal stresses, because we are taking we are connecting that load by using that slip rings, right? So that's why the losses are occurring more in the slip ring induction motor. Okay, and you may have studied in machines also that slip ring induction motor is having more losses. Okay, but there is one more advantage also, that we can add the external resistance. So that type of motor is also sometimes preferred in some applications. Okay, then other faults which occur on the rotor of motor includes failure of bearings and faults in the starters and associated circuits. Okay, so uh, failure of bearings. Okay, if uh, that may be of any type of motor, then uh, means rotor, then faults in starters. So different types of starters we are using: star delta, DOL starter. Okay, so different starters we are using for three-phase induction motors. So if any fault will occur in that starter, then also we have to protect the motor. And associated circuits means in the circuit, if any fault is occurring, we have to protect the motor by using the relays. Okay, so these are the faults occurring in the induction motor: stator faults and rotor faults. Stator winding fault and rotor faults. If you consider the rotor, you should imagine the rotor construction. Then you can imagine the faults occurring in the system. Okay, then next is the abnormal conditions. So what are these abnormal conditions? So first is the prolonged overloading protection. Okay, prolonged overloading protection means what? Actually, when we are actually the rated capacity of that machine is already given. Means up to that particular point you can connect the load. But if you increase the load on motor, you can connect that load for some time only, or for few minutes only. But if that load persists for more time, then it will damage your motor. Okay, it will damage your motor. So we have to protect the motor against such type of loads. So that is nothing but the prolonged overloading protection. So this is caused by excessive mechanical loading, a short time cyclic overloading. Okay, means if you give any external or mechanical load, okay, on the motor, and short time cyclic overloading. Okay, short time cyclic overloading means for some period you are giving that load. Okay, then also uh, your motor get damaged. Then this causes excessive rise of temperature of winding and deterioration of insulation. Okay, including resulting in winding fault. Okay, means all of you know that when load increases, the current increases, right? If the current increases, the temperature increases, and if temperature increases, it will heat the winding and it will deteriorate the insulation. म्हणजे insulation तुमचं खराब होणार आहे. Okay, so resulting in the winding fault. Okay, so if there is deterioration of any breakdown of the insulation, then there will be the inter-turn faults, means sometimes two phases get short circuited there, sometimes the single phase get or two phase to ground faults, means such different types of faults will occur. Okay, so overload protection should be provided in electrical machines irrespective of the size, rating of the motor and type of the load driving. So if any type of motor you are using, okay, any type of motor you are using, we have to protect that motor. Okay, so we are using the relays for this motor protection. So again, we are using the differential relay. Means again, there is a differential relay protection scheme for this induction motor protection also. Okay. Then stalling protection. So can anyone tell me what is mean by this stalling? So can anyone tell me what is mean by this stalling? Screen is visible, na? Yes or no? Screen दिसते ना सगळ्यांना? Okay. So what is mean by this stalling? Yes. Stalling means what? Stalling means what? In induction motors, all of you studied? Yes, stalling means what? Anyone? Okay, so I'll tell you. So all of you studied the motor construction, right? So stator is there, rotor is there. Okay, stator and rotor is there. So what is happening at start? At start, when your motor will start, and before that, what happens? This motor is having a tendency that when it is going to start, that time the stator teeth and rotor teeth uh, get interlocked there. Okay, means they are having tendency of interlocking of the stator teeth under the rotor teeth. Okay, so that get interlocked, and what happens, then your motor will not start there. Okay, your motor will not start there. So you have studied that these bars are skewed. Okay, म्हणजे जे रोटर कंडक्टर्स असतात, रोटर कंडक्टर्स आर देअर, these are not straight. Okay, these are skewed. Okay, म्हणजे these rotor conductors are skewed means they are not straight. Okay, means we are putting that actually it should be in such a way. If you are putting in these two here, if you are putting one conductor, right na, so actually all should be in a straight line, but these are not in straight line. These bars are skewed. Okay, skewed means likewise there is construction. Okay, so in this way these bars are placed here. Okay, so why this is? Because this motor is having tendency to uh, uh, stop the starting. Okay, because they get interlocked, means the stator teeth and the rotor teeth get interlocked here, so that they refuse to start. Okay, means your motor will refuse to start. Okay, so here the stalling protection means due to mechanical problem or overload during period of starting, motor may stall and refuse to start. Okay, it will refuse to start. So during stalling motor, it draws huge current. Okay, so when this will happen means when your motor will refuse to start, so that time the huge current will be produced. Okay, huge current will be produced. So hence it is not desirable, and immediate isolation of the motor from supply mains is essential. Okay, so we have to protect the motor against such stalling. Okay, then next one is the unbalanced supply protection. So stalling protection समझ लें. Stalling means what? When your rotor teeth get and status teeth, they are interlocked, so that your motor is not starting, and it is due to the mechanical problem. So this is your mechanical problem, or the overload during the period of starting of motor. Okay, and if there is also overload at the starting of motor, so your motor is refusing to start. So uh, if it refuses to start, and what happens, you are giving supply but your motor is not starting, so it will draw the huge current. Okay, motor will draw the huge current. So we have to protect the system, we have to protect the motor, so we have to disconnect the supply. Okay, so that is nothing but the stalling protection. Okay, then next point is the unbalanced supply voltage protection. Unbalanced supply voltage protection. So it is just like we have seen, all of you know the unbalancing, right? Unbalance means when the angle between any two phases get changed there, that is nothing but your unbalanced system. Okay, so if the angle between all the three phases is equal to 360 degree, but the angle between any two phases should be 120 degree, and that should be same. So if that angle gets changed, your system becomes unbalanced. Okay, your system becomes unbalanced, and the current will flow towards the earth, that is the neutral wire. Current will flow through the neutral wire. Okay, so the unbalanced three phase supply causes negative sequence current. So we have studied that. So when there is unbalanced supply, so negative sequence currents are produced to flow in the motor, that likely to cause overheating of the motor. So we have to protect the motor against this unbalancing. Okay, means against this negative sequence currents. Okay, so these negative sequence currents are shown by I2. Okay, I2 suffix is 2 for negative sequence. Okay, the next one is the single phasing protection. Single phasing means sometimes it is a general protection. Single phasing protection means any one of the line get disconnected from the three phase supply, so your system becomes single phase, right? So this single phasing in motors cause when one of the supply lines get disconnected. Okay, so all of you know sometimes you are getting the single phase supply, or sometimes this happens when you are single phasing may occur sometimes. Okay, so uh, when any one of the line get disconnected, then the single phasing is occurring, right? Means the supply get continued there, supply get continued, but it is single phase supply. Okay, now they may be occurred due to blowing of fuse or open circuit in one of the three phase connection. Okay, so if your fuse blows, okay, so it will also disconnect the supply, or open circuit. If any one of the phase get open circuited, due to that also this single phasing occurs. Okay, then in such conditions, motor continues to operate as a single phase induction motor provided that the load does not exceed the 57.7% of the normal rating. Okay, but its load carrying capacity decreases. Okay, so whatever be the rated capacity given, as per that rated capacity, only 57.7% of the load only that motor can carry now. ओके, म्हणजे जर सिंगल फेजिंग झालं, ओके, म्हणजे एखादी लाईन डिस्कनेक्ट झाली किंवा एखादी फ्यूज गेली तर काय होतं, सिंगल फेजिंग होते. सिंगल फेजिंग झालं तर काय होते, जर जे काही मोटरची कपॅसिटी दिलेली आहे, ओके, तो लोड कॅरी करण्याची, सो दॅट कपॅसिटी गेट डिक्रीज देअर. म्हणजे 100% म्हणजे तुम्ही फुल लोड देऊ शकता ज्यावेळी मोटरला 3 फेज सप्लाय असेल. पण जेव्हा सिंगल फेजिंग होईल त्यावेळी तुम्ही किती लोड देऊ शकता, तर 57.7% ऑफ द नॉर्मल रेटिंग. ओके, सो दिस सिंगल फेजिंग मे कॉज एक्स्ट्रीम magnetic unbalance, reduction in torque, and overheating due to negative sequence currents. Okay, so this single phasing is causing extreme magnetic unbalance. Okay, so extreme magnetic unbalance is there, then reduction in torque get decreased, and overheating due to negative phase sequence currents. Okay, because there is unbalance between the phases. Okay, unbalancing is there because one phase is disconnected, so that's why the phase negative phase sequence currents will be there. Okay, then operating under this mode lead to damage to motor, and therefore protection is provided for single phasing of the motor. Okay, so if you operate your motor with the same system, means with this single phasing only, so it will damage the motor. Okay, so we have to protect that motor against this single phasing. Sometimes what happens, single phasing is occurred and still we are giving the load as per the rated capacity. So that time there will be winding faults. Okay, so that single we have to protect the motor against the single phasing also. That is the abnormal condition. Then next is the under voltage protection. So the under voltage supply condition will lead to drawing more current from the mains for a given load. Okay, means if under voltage is there, so if under voltage, the system or your motor will draw the excessive current from the mains, so we have to protect your machine against this under voltage protection also. And next is the reverse phase protection. Okay, so the direction of polyphase induction motor is reversed if the phase sequence is changed. Okay, so I think you have seen the reversal of motor. Okay, you may have performed practical when the phase sequence changes. You can reverse the direction of rotation of the motor. Okay, by changing the phase sequence. Means, for example, phase sequence is R, Y, and B. Okay, phase sequence is R, Y, and B. And if the sequence get changed, means if it is R, B, and Y, then whatever be the previous direction of rotation, when suppose if the sequence is R, Y, and B, your motor is rotating in clockwise direction. And if you change the phase sequence, that is R, B, and Y, your motor will rotate in the opposite direction. So means if the phase sequence gets changed, okay, then the direction of rotation also changes. Okay, so we have to protect that also. Means we have to take care while such conditions are occurring. Okay, so these are the abnormal conditions which are occurring, and you have to protect the motor against all faults and against all abnormal conditions. Okay, now so this is our three-phase induction motor protection, and now there is bus bar protection. Okay, bus bar protection. We'll see that bus bar protection. Okay, now bus bar. All of you know about bus bar, right? Now, so when we are considering the transmission line, so we cannot take the direct supply from that transmission line, right? No, right. So we have to decrease that voltage, and by using the step down transformer, again the supply is given to the load by using these bus bars. Bus bars are there, feeders are there, right? So by using these means, we are providing the electricity to the load. Okay, so uh, we have to protect these bus bars also. In this switchgear and protection, we are seeing the protection of our whole power system. So up to this point, we have seen the protection of transmission lines. Also, in equipment protection, whatever be the equipments coming under this power system, that is from the generating end to the load end, that is the distribution end. We are seeing all the equipments, that is the generator, transformer, what induction motor, and this bus bars protection. Okay, uh, so everywhere we have to every point we have to consider here. Okay, so when the fault occurs on the bus bars, whole of the supply is interrupted. Okay, and all the healthy feeders are disconnected, right? We are using bus bars, and that by using bus bars we are giving supply to the feeders. Okay, so different types of feeders are there. We have seen that is also, that is the ring main system is there, radial system is there, interconnected system is there. So these are the different types of feeders which we have seen. So if the fault is occurring in the bus bar only, okay, जे जर मेन लाईनलाच जर फॉल्ट असेल तर कम्प्लीट फीडर्सचा सप्लाय काय होणार आहे, डिस्कनेक्ट होणार आहे. ओके, and the majority of faults is single phase in nature, and these faults are temporary. Okay, so actually when we are considering this bus bar protection, so in that single phase faults are occurring more. Okay, and these faults are also for a short time only. Okay, because we are using relays there, and the bus zone fault occurs because of various reasons, like failure of support insulators. Okay, so the bus zone fault. Okay, bus zone fault means what? Okay, for the bus bars also there are zones. Okay, so this bus zone fault occurs because of various reasons, like failure of support insulators. Okay, support insulators, then failure of circuit breakers, then foreign object accidentally falling across the bus bar. Okay, so if your circuit breaker fails to operate, okay, then foreign object accidentally falling across the bus bar. ओके, म्हणजे एखादा एक्सटर्नल ऑब्जेक्ट, काहीतरी सपोज एखादं झाड वगैरे पडतं, that time also you have to protect the bus bar, etc. For removing the bus fault, all the circuits connecting the faulty section needs to be open. Okay, so if such faults are occurring in the system, we have to we have to disconnect that faulty section, right? Now, so that faulty section is disconnected by using circuit breaker. But where actually that fault is occurred, okay, where actually that fault is occurred, that is detected by the relays only, okay, by the relays only. Now, the most commonly used schemes for the bus zone protection are, there are different protecting schemes. First is the backup protection, and second is the differential overcurrent protection. Okay, so in that again there are two types, that is the circulating current protection and voltage overload, voltage over voltage protection. Okay, so just a minute.